pop. Mimi splashing, she won't stop. Swish, swoosh, water fun. Little waves and giggles run. Splash, splash, let's look. The yellow ducky floats on top. It swims around and will not drop. No, no. But look, the car goes down so fast it sinks right to the bottom blast. Why did it sink? Why did it fall? Why does the sponge not sink at all? One goes up and one goes down. Why do things swim and why do they drown?
So why does the metal toy sink while the rubber duck floats on the surface of the water? It's all about density. All objects are made up of molecules, which are tiny particles. In the duckling, these particles are far apart from each other, and there is a lot of air between them. That's why the duckling floats so easily on the surface. But the metal toy is different. Its particles are very close to each other. Even in water, they are not that close. That's why the toy sinks. And a sponge is an unusual object. Its particles are also far apart, but when the sponge gets wet, water fills the voids inside it, and its density increases. Let's conduct an experiment and find out which objects sink and which do not. To make it easier to see, we will conduct the experiment in an aquarium, but any container with water will do. The first object is a coin. What do you think, Mimi? Will it sink?
Yes.
Yes. The coin went to the bottom. The second object is a wooden block. What do you think, Mimi?
Yes.
Let's take a look. The block stayed afloat. How about a tangerine? Don't eat it, Mimi. Will it float?
Yes.
The tangerine doesn't sink either. Wow. Now let's take identical objects but made from different materials, like these spoons. Will the metal spoon float?
No.
No. It ended up at the bottom of the fish tank. Next is the plastic spoon. What will happen to it?
Yes.
Its particles keep it from sinking. And how about the wooden spoon? It stays closer to the top. As you can see, Mimi, it's not so important what the object is. What matters more is what material it's made from and how its particles are arranged. Well, now is the perfect time to play with friends in the pool under adult supervision and share your new knowledge. Now you can tell everyone that it's not magic that keeps objects on the surface, but their density.
Friends are playing in the sand. Mimi makes a sand friend, building it by hand. She finds a little pebble, tiny, black, and small. Look, a funny stone. Mimi smiles to all. Pop, the pebble jumps, hops out with a flip, and sticks onto a toy. How did it do this trick? How did it do this trick? Who helped this little pebble stick to the car so quick, so quick?
Mimi, this magical little stone is called a magnet. Its magic is actually its magnetic field. Every magnet has two poles, a south pole and a north one. The blue side is south, and the red side is north. Opposite poles always pull towards each other, just like best friends. And the same poles push each other away. It's the magnetic field that pulls things made of metal. Let's do an experiment to see what the magnet will pull and what it won't. Make sure you call a grown-up for help.
Grown-up time.
For our experiment, let's take a little twig, a paper boat, a paper clip, and a teddy bear. Where's your magnetic fishing rod? Let's make one ourselves. We just need a string, a stick, and a magnet. Let's put all our items on the table and see what the magnet picks up. It didn't catch the wood, or the paper, or a teddy bear. And what do we have here? That's right! Only metal gets pulled. And you can even create a really cool game with a magnet. Want to try? Let's take some paint, a piece of cardboard, and a magnet. Dip the paper clips in the paint. Use some blocks or other things to prop up the cardboard. Place the painted paper clips on top and put the magnet under the cardboard. Then start moving the magnet under the cardboard and wow! Our paper clips are drawing a picture. That's because the magnet can pull metal even through the cardboard. Magnets look like magic, but they're actually science. They can pull and push objects with their magnetic field, even though we can't see it. Now you know how the magnet works, and you can surprise your friends with your knowledge by drawing new, beautiful pictures.
Me, paints today. Colors, colors, come and play. Me, where's the blue? Me, what to do? Rainbow, rainbow, up so high. Rainbow, rainbow in the sky. Me, jump and cheer. All the colors now are here.
Leave the paint bucket and let's take a look inside a rainbow instead. Is that some kind of flood here? No, that's just how a rainbow appears. When a sunbeam hits a raindrop, it splits into colors. Each tiny raindrop makes its own little piece of rainbow, and together they swirl in a dance of colors.
Wow.
Mimi, do you know how many colors it's made of? Well, tell us. That's right, Mimi. There are 7 colors in a rainbow. Actually, there are many more, but our eyes only see exactly 7. This is real rainbow fun! Mimi, how about we create a real rainbow at home?
Wow.
Quick, let's fly to our house.
Grown-up time.
Let's get started. We'll need a glass, a bottle of water, a piece of paper, and a flashlight. Pour water into the glass, place a white piece of paper under it. Then, shine the flashlight through the glass onto the paper, and voila, there's a rainbow. No magic, just science. If you shine it straight on, there won't be a rainbow. You need to do it at an angle, and it will appear. So it's not magic at all. It's science. The sun just plays with the rain and creates a colorful wonder. Light passes through the droplets, coloring the sky. Now you know how a rainbow appears. And with the trick of making one at home, you can surprise all your friends.
Oh, sunshine! Hello! I'm going to run out and play. Sunny, sunny, sun. Hello, hello. Warm my cheeks. Glow, glow, glow. Clap, clap, clap. Hands up high. Hop, hop, hop. Jump and fly. Run, run, run. Count to 3. 1, 2, 3. Chase with me. Draw, draw, draw a circle round. Big bright sun on the ground. Sun, sun, don't go away. Come back soon tomorrow day.
The sun goes down past the horizon.
Sunshine, where are you? Where did the sunshine go? Why is it night?
To understand, we need to look from way up high.
Whoa, that's what our planet looks like?
Our planet keeps spinning. It turns different parts toward the sun.
But I never feel like I'm spinning.
It's like being in a car. You sit in your seat and don't feel it, but you are moving fast with the car. You move with Earth the same way.
Yes!
When your town faces the sun, it's daytime. But for your friend Vinny on the other side of Earth, it's night. When you go to sleep, she wakes up. Now it's her turn to run and play in the sunshine.
Aha! I think I get it. Grown-up time.
For the experiment, we need a desk lamp, a big ball, and stickers.
This sticker is me. And this sticker is Vinny.
The lamp is the sun.
Now it's night for me. And for my friend Vinny, it's day. The planet spins. Now Vinny has night and I have day. Yay!
Earth keeps spinning, so there is day and night everywhere.
And my friend Vinny is playing in the sunshine instead of me right now. And when I wake up in the morning, Vinny will be going to sleep. Good night, sunshine. See you tomorrow. Balloon, balloon, up you go to the sky, so bright, so slow. Mimi smiles, Croco too. Fox says, hey, I'm flying too. We laugh and fly around, way up high above the ground. Rainbow smiles and says hello. Stars are shining, twinkle, glow. Fly, 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 so high, so high. Balloon, balloon, up to the sky. Oh no!
What a wonderful dream! In the real world, you'd fall from the sky down to Earth because of gravity. It's an invisible force that pulls everything down. The Earth keeps us from floating away, unless you're a helium balloon. Helium is lighter than air, so it can easily float up despite the pull of gravity. It's like a game of tug of war. Do you know that a balloon can lift light objects? Let's find out what it can do.
Grown-up time.
We have a helium balloon, a feather, a paper airplane, a wooden spoon, and a toy car. Of course, the balloon will lift the feather with no trouble at all. It's so light. But what's next? The paper airplane is taking off too. But things are a bit different with the wooden spoon. We'll need more balloons to lift it. But even a whole bunch of them won't make the toy car fly. It's just too heavy for that. Mimi, do you want to fly too? Unfortunately, you can't do that with regular balloons. They aren't strong enough to lift you. And now you want to lift a whole house? That only works in cartoons. In real life, you'd need so many balloons they would cover the entire sky. What a fun party you're having! You can share everything you've learned with your friends, like how the Earth pulls everything down, while helium can make a balloon fly.
Wow!
Yay!
And not just balloons.
Bouncing, bouncing ball, where are you? We've got some chasing to do now. Bouncing, bouncing ball, where are you? You're making such a big boom pow! You keep on jumping around the room. You make a crash. You make a boom. Bouncing, bouncing ball, where are you? We really need to slow you down. Bouncing, bouncing ball, slow down, please. You're acting just like a rover. You hit the table, clang and crash. You spill the cup, splish and splash. Bouncing, bouncing ball, slow down, please. Why do you bounce so high? Oh, tell me, why, oh, why? How can you jump right to the sky? What's inside that makes you go up and down, fast and slow? Is it magic? Is it air? Is there something special there? Bouncing, bouncing ball, where are you? We really want to know.
Wow, such a small ball, but it caused so much trouble. But why does it even bounce at all? When a ball hits a surface, it compresses, and the air particles inside push the walls back out, making it jump up. But with every bounce, the ball goes lower and lower because some of its energy is getting lost. For example, a soccer ball bounces for quite a while, but not very high. It doesn't have that much air inside, and the material it's made of isn't as stiff or elastic as, say, a basketball. A basketball bounces higher and longer. It has a lot of air inside, and it bounces off surfaces better because of its material. A beach ball is much lighter. It has the thinnest skin, and the air inside isn't under as much pressure as the others, so it hardly bounces at all. The bounciness also depends on the floor. The softer the floor, the weaker the bounce. So remember to play carefully with balls to stay out of trouble.